Okay. So this time we focus on the object-oriented programming. No? So the OOP or object-oriented programming is a core paradigm in Java, especially critical for Android development because it allows developers to structure their code into into distinct object, its encapsulating state or the attributes and behavior or the methods. Now, so this paradigm organizes code into reusable and manageable units, which is essential for building complex Android applications. In object-oriented programming kasi, the key concept include classes, objects, inheritance, encapsulation, polymorphism, and abstraction, which together support modular, scalable, and maintainable code. So classes and objects are fundamental to Java's OOP structure. So a class acts as a blueprint for creating objects, defining attributes and methods that the objects or instances of the class will have. Let's say, for example, in an Android app, a user class might represent its user profile with attributes like username and methods like update profile. In practice, creating objects from classes allows Android developers to handle individual elements of an app systematically, making it easier to create consistent functionalities across the application. Encapsulation in Java refers to bundling data, yung attributes natin and methods, within a class and restricting direct access to certain components. So, using access modifiers like yung private, public, and protected, we as an Android developers can control the visibility of class members, keeping the internal details hidden from other classes. For instance, in an app, since sensitive user data could be encapsulated within the user class, and other classes, would only interact with this data through defined getter, and setter methods, promoting data security and integrity. Inheritance is another essential OOP concept in Java, enabling classes to inherit properties and behaviors from other classes, reducing redundancy. Android development frequently uses inheritance for shared features across classes. For example, an Android activity class which represent a screen in the app can extend the app com at activity class, inheriting essential properties and methods for user interface management. So allowing us as developers to focus on building unique app features rather than rewriting common functionalities. Polymorphism and abstraction complete the OOP foundation in Java for Android development because polymorphism allows method to perform different actions based on the object calling the method. So adding flexibility to code design, abstraction on the other hand enables Android developers to define complex class structure at a high level without detailing every implementation. In Android, abstract classes and interfaces are common, such as a recycler view, that adapter, which abstract how list and grid are displayed in the app. So, these principles make Java OOP a powerful approach to Android development, offering organized, scalable, and easily maintainable application. I just want to continue the video presentation as what we have during our last discussion. Okay?
An object has three characteristics. It has a state, behavior, as well as identity. The state represents the data of an object. Now, the behavior represents the action of an object, such as start, stop, etc. Identity is used internally by the Java virtual machine to identify each object uniquely, right? So the value of ID is not visible to the external user. So let's think about maybe a car, and let's call it a Ferrari. The color is red. The model is 2015. These are the states, right? So this car starts and stops. So starting and stopping are behaviors. Object and class example. So let's make an example with objects and class. For instance, we define a car class, and the properties of an object car would be model, color, and year. An object also executes some actions. A car is capable of performing the following actions, right? Start, stop, and accelerate. Now, as you can see on the slide, for different values of properties, model, color, year, in the class car, we will get different car objects. So in our example, we have one class, but we also have 3 objects. Cool. Class declaration. Every Java application must have at least one class definition. A class is declared by use of the class keyword. The class body is enclosed between curly braces. The data of the variables are defined in the class, and these variables are called instance variables. The action code is written in the method, and all code blocks are in the class body. So variables and methods are defined in the class, and these are members of the class. Creating an object. An object is created from a class. In Java, the new keyword is used to create new objects. And as you can see here in the slide, we created my car as an object from the car class by using the new keyword. So car, my car, equals new car. And here, my car, the object, is the reference which holds the memory address of the car object. So in this section, we will learn access modifiers in Java. Access modifiers are used for setting the access level to classes, variables, methods, and constructors. There are basically 4 access modifiers in Java. First one, of course, is default, by default. So that means that we will not explicitly declare an access modifier for a class, field, method, and constructor. A variable, method, and constructor declared without any access control modifier is available to any other class in the same package. The second one is public. Public access modifier is accessible from everywhere, and this is the least restrictive access modifier. And the third one is private. The private access modifier is accessible only within class. So methods, variables, and constructors that are declared private can only be accessed within the declared class itself. Private modifiers are the most restrictive access level. So the last one is protected. The protected access modifier is accessible only within the same package and in addition from all subclasses of its class. So in this part, you see the restrictive level of accessibility of modifiers. And as you see here in the slide, the most restrictive modifier is private, and the least restrictive modifier is public. Default comes after private, and protected comes after default. So in this section, we will learn naming convention rules in Java. Java naming convention is a rule to follow how to name your identifiers, like class, variable, method, etc. But it's not enforced. You don't have to follow it. It's known as a convention, so that means it's just a mandatory rule. Guideline, if you're a fan of Pirates of the Caribbean. Anyway, as you see here in the table, the class name should start with an uppercase letter and should be a noun. For example, string, car, system, etc. The method name should start with a lowercase letter and be a verb. For example, start, stop, action performed, etc. The variable name should start with a lowercase letter. For example, first name, year, color, etc. And then by using standard Java naming conventions, you can make your code easier to read for yourself and for other programmers. The readability of a Java program is very important. It indicates that less time is spent on how to understand what exactly the code does. The most important concepts of naming conventions are case-sensitive and camel casing. So Java is a case-sensitive language. For example, hello with the first letter as an uppercase and hello with the first letter as a lowercase are, well, they mean completely different things in Java. Camel casing is a naming convention in which the first letter of the second word in a compound word is capitalized. So you have a name that is combined with two words. The second word will start with uppercase letter always. For example, action performed, first name, etc. Constructors. A constructor is similar to a method. It has the same name as its class. And when a new object is created, at least one constructor will be invoked. Every class has a constructor that is named default constructor. However, constructors have no explicit return type. Now, as you can see in our example, a class can have more than one constructor. So in order to understand the working of a constructor, take this for an example. Let's say we have a class car, and when we create two objects of car, in creating the first object, the new keyword here creates the object of class car and invokes the default constructor, has no parameter to initialize the newly created object. And then in creating the second object, also the new keyword creates the object of class car and invokes the constructor that has one parameter to initialize the newly created object. So let's show you some visual examples about working with constructors. So first, let's create a new Java project. And we can specify the project name as object-oriented. Now don't bother changing the other options and just click the next button. So in this section, just uncheck the create module info.java file and then press the finish button. So in this project, just right-click on the source folder and select New Class. So specify the package name as OOP concept, OOP concept, and the class name is car. Okay, so we create a car class. The states of the car are model and current speed. We declare them as a private identifier because we cannot have access to these variables from another class. So now let's declare a public constructor that's named car, and it takes one parameter, and its name is model. So we declare the constructor as public because we want to be able to access this constructor from another class. So in the constructor method, we assign a parameter to ownVariableModel. This keyword is used to access the same class members. Now don't worry, we will cover this as a keyword in the next slides. So let's declare 4 public methods of the car class. And we declare it as public because, of course, we want to have access to these methods from the other classes. Now, the name of the first method is start with void type. In the start method, we use the print method to display car has started as our message by adding the variable model. The name of the second method is accelerate. So we add 20 miles per hour to the current speed variable by using the add and assignment operator. Then the name of the third method is stop. So in the stop method, we use the print method to display the car has stopped message by adding the variable model. Also, we can set the current speed to 0 because if the car stops, then its speed, of course, is 0. Now, the name of the last method is showSpeed. And in the showSpeed method, we can use the print method to display the current speed of the car by adding the variable model and current speed. So let's save the code. All right, so we're going to need to test this class. So let's create a new class. Right-click on OOP-Concept package and select New Class. Specify the class name as CarTest, and then select the checkbox for the main method. So let's create the MyCar object by using the new keyword. So we pass Ferrari as a parameter to the car class. This process invokes a constructor having one argument. So let's call the methods by using the MyCar object. We can access the properties of an object with a simple dot notation. So if we write MyCar dot, Eclipse automatically brings the properties of class, and we can choose them to add to our code. So we add the start method first, and then accelerate, and then show speed, and then stop, and again, show speed. Okay, so let's run the code in the test class. So you see the results in the console right here. The start method is called and it displays the Ferrari has started message. The accelerate method is called and it sets 20 to the current speed variable. The show speed method is called and it displays the current speed of the Ferrari is 20. The stop method is called and it displays Ferrari has stopped and set 0 to the current speed variable. The show speed method is called again and it displays the current speed of the Ferrari is 0. Okay, so you are now ready to learn the toString method. Been waiting for this. So let's declare 2 variables in the car class. The first one is color with string type, and the second one is year with int type. So let's declare a constructor that's named car, and it takes 3 parameters: model, color, and year. All right, so in the constructor method, we can assign the model to its own variable model, color to its own variable color, and year to its own variable year by using the this keyword. So let's declare the toString method of the car class, and the toString method returns string. Now, we return name, color, and the year variables by using the plus operator in this method. So let's save the code. Okay, so let's pass the test class carTest, and let's create a new object. So its name is myCar1. Now we pass 3 parameters to the car class. They are Ferrari, red, and 2015. And now we add the object myCar1 to the print method. Now, if you print any object, the Java compiler internally invokes the toString method. So let's run the test class again. And do you see the result in the last statement? Of course. The toString method is called and it prints model is Ferrari, color is red, and year is 2015. So let's open the car class, and we invoke this constructor and the toString method of the car class. Packages. A Java package is a group of similar types of classes, interfaces, and other sub-packages. Now, if you have a large-sized project that consists of hundreds of Java classes, you really need to organize them into packages. You can think of packages like file directories in your PC. So this will allow you to categorize files, control access to your classes, and avoid potential naming conflicts. Classes with the same name can be put into different packages. So then packages avoid name collision. So the package keyword is used to declare a package. In our example, let's declare a package vehicle.car. So here, vehicle is a top-level package and car is a sub-package, right? Now, of course, there are some rules to define packages. Package declaration is done at the beginning of the source file. Only one package declaration can be done per source file, and if no package is declared, then the class belongs to the default package. And the package name must be hierarchical and separated by dots. Types of packages. So we have 2 types of packages in Java. Built-in package, the already defined package like java.lang, java.io, etc. They're known as built-in packages. You can also have a user-defined package. So the package we create is called a user-defined package. For example, the one that we used earlier, vehicle.car. That's a user-defined package. Import keyword. So we can use the import keyword to import built-in and user-defined packages into our Java source file. Our class can refer to a class that is in another package, and we can use its name directly in your class. We can access the classes and interface of another package with the import keyword. So we have two different ways of how to import any class into different packages. The first one, if you import the package name dot class name, then only this class will be available for use. For example, you see this on the slide. If we use import vehicle.car.ferrari, that means that we will use only the Ferrari class in the subpackage car in the top package vehicle. Yeah? So the second way to import, if you use a package name asterisk, then all the classes and the interfaces of this package will be accessible, but the classes and the interface inside the subpackages will not be available for use. Now, there is one exception to the import rule. All classes in the java.lang package are imported by default. But that means that we do not need to import classes in the java.lang package into our code. The system class can be given as an example for this exception. The system class is predefined in the java.lang package, so we can use it in our code without importing. Sequence of program. So as you see here in the diagram, in Java, a Java source file can contain any or all of the following three internal parts: a package statement, import statements, and a public class declaration. A Java source file should have a public class declaration. All other statements are optional. The program should be written in a flow package with imports and class. So why don't we do some examples with packages? In fact, we did an implementation of packages in all of our earlier examples, but we do need to learn the package concept, I think, in detail. So let's get into it. So in the Object-Oriented Programming project, just right-click on the source folder and select New, Package. Specify the package name as package operation. Okay, so let's create a new class. Right-click on package operation and select New, Class. Now specify the class name as multiply, and it means that the multiply class in the package operation package. So let's start to code. Let's declare an int method, multiply, with two int parameters, a and b. And we return a multiply b expression from the method. Now let's create a new package for the test. Right-click on the source folder and select New, Package. Specify the package name as package test. Okay, so let's create a new class. Right-click on the package test package and select New and Class. Specify the class name as test and select the checkbox to add to the main method. Now, first we need to import the scanner class for getting the input from the user. And we choose the import scanner class in java.util package to import the scanner class. Java.util is a built-in package. And now we see a message to enter two numbers by using the print method. So why don't we go ahead and declare two variables that are named number 1 and number 2 with the int type, and assign the next int methods of the scanner class to these variables. Great. So now let's create an object from the multiply class by using the new operator. So the multiply class is not part of this package, so we got an error, right? You're expecting that? So what does that mean? We've got to import this class. Now, in order to import this class, just hover your mouse pointer on the multiply keyword and import options are shown. And we'll choose the first option, import multiply in package operation. Okay, so it looks like it's added after the scanner class definition. Now, this is what we would call a user-defined package. So let's print the multiplication of numbers, and we will call the multiply method of the multiply class, and we pass two numbers as parameters. Okay, so let's run the code. We enter 12 and 8. The multiply method in the multiply class is called, and it displays result is 96. So let's try to change the access modifier of the multiply method in the multiply class. So if we change the public to private, and let's save the class. So see how we get an error in the main method, because the method multiply is not visible to the other class. So in these cases, Eclipse can show us a quick fix dialog. Now this dialog provides a whole list of possible corrections. Now, if we want to solve this problem, just select Change Visibility of the multiply method to public option. Okay, so let's open up the multiply class and see our changes. Let's create a new class and specify the package name as method operation and class name as add. Let's declare an int method add with two int parameters a and b. We return a plus b as the expression from the method, and we'll save the class. Now let's open the main class test. We have two classes in the package operation package, multiply and add. So if we use the asterisk mark after the package definition, we can access all of the classes in this package. So let's create an object from the class add. And see how we didn't get an error, so there's no need to import this class. Let's print the sum of the numbers. We call the add method of add class, and we pass two numbers as parameters. Okay, let's run the code. We'll enter 12 and 8. So the multiply method in the multiply class is called, and it displays result is 96. Add method in the add class is called, and it displays result is 20. In this section, we'll explore the static keyword of the Java language in detail. We'll learn how we can apply the keyword static to variables, methods, blocks, nested classes, and just see what difference it makes. So the static keyword is used for memory management in Java. It's a keyword that is very useful, and it's used for sharing the same variable or method of a given class. static keyword usage. So have a look at this slide. We use the static keyword to declare static variables, methods, blocks, in our class. And also, we'll be able to define the static method in interface classes in Java 8 and later. Static variable is used for fulfilling the common requirement. For example, a school name of students. The school name is common for all students, so if we declare static school name variable, it'll allocate memory only once in the class at the time of class loading. A static variable can be accessed directly by the class name, and it doesn't need any object. Now, the static method is a method which belongs to the class and not to the object, right? A static method can be accessed directly by the class name and doesn't need any object, same as a static variable. Static block is a block of statement inside a Java class that will be executed when a class is first loaded into the Java virtual machine. And we will also cover nested class and interface in the next slides. But for now, let's make some real-life examples by using the static variables and methods. So in the Object-Oriented Programming project, just right-click on the source folder and select New Class. Specify the package name as static example and the class name as car. So let's start to write a program that implements speed operations of a car by using static variables and methods, such as show speed, speed up, speed down, and stop actions. Now first, let's declare two static integer variables. First one is current speed with the initial value of 0. And the second one, max speed with the initial value set to 180. So now let's declare a static void method that's named showCurrentSpeed, and we'll give it a parameter that's named speed. So we will use this method to print the current speed by using the print method. And we're going to call this method from the other methods in this class. So we'll write a method once, and then we can use it multiple times, right? We do not have to rewrite the entire code each time. You remember that from earlier? So let's declare a static void method that's named speedup, and we'll give it a parameter, call it increase. So in this method, we'll assign the current speed plus variable increase to current speed by using the add and assignment operator. So if the current speed of the car is greater than the max speed, then we show the current speed. And also, we can give the please slow down message by using the print methods. So if the current speed is smaller than the max speed, that way we only show the current speed by calling up the showCurrentSpeed method. So let's declare another static void method that's named speedDown, and let's give it a parameter called decrease. So in this method, we'll assign the current speed minus variable decrease to the current speed by using the subtract and assignment operator. All right, that makes sense. So then we show the current speed by calling up the showCurrentSpeed method. So let's declare the third static void method that's named stop, and that one, of course, has no parameter. So in this method, we just assign a 0 value to the current speed variable, and we show the current speed by calling the showCurrentSpeed method. Okay, so let's create a new class for the test of car. Right-click on Static Example and select New Class and specify the class name as Test, and then just select the checkbox to add it to the main method. Now, a static method can be accessed directly by the class name, and it doesn't need any object. So let's call the methods of the class by using the class name directly. So first, we call speedup and pass the value 60 as the parameter for increasing speed. Then we call the speedup method again and pass the value 100 as a parameter for increasing speed. Then we call the speeddown method and pass the value of 50 as a parameter for decreasing speed. And then finally, we can call the stop method. All right, so let's run the code and review the results. So the initial value of speed is 0, and look at that, we speed up to 60, and the current speed is 60. Then we speed up to 160, which is 60 plus 160, so the current speed is 220, and 220 is greater than the max speed value of 180, so we get the please slow down message. And then we speed down 50, and 220 minus 50, and the current speed is 170. And then finally, we stop the car and set 0 to the current speed. Wow, what a ride. So if we try to create a car object by using the new keyword, let's call the speedup method and pass a value of 40 as a parameter. Now there's no error, but we do get a warning message that the static method speedup from the type car should be accessed in a static way. So this code works, but it's not recommended to do it this way. All right, so let's run the code, and you see the same results. So how about that? I think that greatly develops your understanding of what a static variable and a static method is. You can review the material, of course, or you can take what you've learned and move along to the next bit. Nested and inner class. So in Java, we may define a class within another class, and this class is known as a nested class. There are two types of nested classes in Java. First one is non-static nested class, and that's known as an inner class. And of course, the second one is the static nested class. So let's talk about non-static nested classes first. So non-static nested classes, or inner classes, may have access to all the members, such as static and non-static variables, methods of its outer class. Also, an inner class may access private variables and methods of its outer class. Static nested classes do not directly have access to other members, such as non-static variables and methods of the enclosing class, because it is, by its nature, static. I tell you what, let's clear it up by doing up some examples, and that'll help us understand it better. So in the Object-Oriented Programming project, just right-click on the source folder, select New Class, specify the package name as Nested Class, and the class name as Static Nested Example. So let's start to write a program that accesses variables from the nested class. Okay, so let's declare a static int variable a with an initial value of 5. And let's declare a private static int variable b with an initial value of 10. Now let's declare a non-static variable c with an initial value of 15. Okay, so let's try to access these variables from the static nested class. Now we need to, of course, create a static nested class in this class. So let's create the static nested class that's named static nested class. So in this class, we create a void method, and we'll call that show. Now in this method, we can use 3 print methods. So in the first print method, we can access static variable a. In the second print method, we can access private static variable b. And in the last print method, we cannot access non-private static variable c. This statement gives a compilation error because the static nested class does not have, it cannot, it won't ever have direct access to a non-static variable. So, what do? We'll put a comment on this line. Okay, so let's create a new class for the test of the static nested class. Right-click on the nested class package, and then select New Class. Specify the class name as Static Nested Test, and then select the checkbox to add to the main method. Now, in order to access a static nested class, we first use the outer class, and then we use the dot operator and nested class. Outer class is static nested example, and the inner nested class is static nested class. So now let's create a nested object by using the new keyword. And we'll call up the show method to print the values of the variables. Okay, so let's run the code. And you see the values of the variables, a equals 5 and b equals 10. So now let's do an example with inner class. Now, I always like to think of myself as having inner class. But let's create a new class. Right-click on the nested class package and select New Class. Specify the class name as inner class example. And then let's copy the declaration of the 3 variables from the static nested example class. Okay, now let's try to access these variables from inner class. We need to create an inner class for this class. So let's create an inner class that's named inner class. So in this class, we need to create a void method called show again. And we'll use 3 print methods. In the first print method, we can access the static variable a. In the second print method, we can access private static variable b. In the last print method, we can access non-private static variable c. This is an important point, right? In the static nested class, we couldn't have access to variable c, but we can access in the inner class, right? Okay, I'm glad we cleared that up. Let's create a new class for the test of inner class. So right-click on the nested class package and select New Class. Specify the class name as InnerTest, and then select the checkbox to add to the main method. Now, in order to instantiate an inner class, we must first instantiate the outer class. Then create the inner object within the outer object. So let's create an outer object by using the new keyword first, and then we'll create an inner object. Okay, so let's run the code. And you see the values of the variables. A equals 5, B equals 10, and C equals 15. Excellent. Very well done. In this section, we will learn object-oriented programming and its implementations. First, we will learn fundamental subjects of object-oriented programming, inheritance. Then we will learn method overriding. Then we will learn how to use super and this as keywords. Then we'll play around with how to use the final keyword. And then we're going to learn abstract classes. And then we will learn interfaces. And then we will learn polymorphism, which is not a religion. Then we will learn encapsulation. Inheritance. So inheritance is a fundamental concept of object-oriented programming. It's used when we have a is-a relationship between objects. In Java, all classes can inherit variables and methods from another class. Inheritance enables us to reuse existing code. So in our example, we have a superclass, vehicle. All vehicles have a type, model, and max speed. Also, all vehicles can start and stop, right? So this is the base class. Also, we have two classes that are named car and motorcycle. So the car and motorcycle classes are subclasses of vehicle. So we can use the extends keyword by the subclass to inherit the features of the superclass. So the car and motorcycle classes inherit variables and methods from the vehicle class. And there's no need to declare these variables or methods again for the car and motorcycle classes. The car class has its own variable that's named isAutomatic, and the motorcycle class has its own variable that is named MotorType. So in the Object-Oriented Programming project, just right-click on the source folder and select New Class. Specify the package name as Inheritance and the class name as Vehicle. So now let's start to write a program that prints the properties of subclasses by using inheritance. The vehicle class is a superclass. So let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with string type, and the variable max speed with int type. Now let's declare a void type method, print, to display the values of type, model, and the max speed variables. And we'll use the print methods. So finally, we'll save that code. Okay, so now let's start to declare subclasses. Okay, so let's create a new subclass. Just right-click on the inheritance package and select New Class. Specify the class name as car. Now, in order to implement inheritance, we have to add the extends keyword after the subclass car. So our subclass car extends the superclass vehicle, and this just means that the subclass car inherits the print method and the variables from the superclass vehicle. So don't forget to save the code. Now, let's create another subclass. Right-click on the inheritance package and select New Class. Now specify the class name as motorcycle. Our subclass motorcycle extends the superclass vehicle. So this means that the subclass motorcycle inherits the print method and the variables from the superclass vehicle. And the motorcycle class is empty. And then finally, we can save the code. All right, so let's now create a new class for testing inheritance. So just right-click on the inheritance package and select New Class. Specify the class name as Inheritance Test, and then select the checkbox to add to the main method. So now, let's start to create a new car object. If you write car object and a dot operator, then you will see the variables max speed, model, and type, and the print method coming from the superclass vehicle. So let's assign car as a value to the type variable, Ferrari as the value to the model variable, and then add the value 320 to the max speed variable. Now let's call the print method from the superclass vehicle. Okay, so now let's run the code, and there you see the results in the console. Type is car, model is Ferrari, and the max speed is 320. All of these properties are inherited from the superclass vehicle. Perfect. So let's start to create a new motorcycle object, shall we? So you see the same properties and methods coming from the superclass vehicle. So let's assign motorcycle as the value to the type variable. Kawasaki as a value to model variable. And the value 180 to the max speed variable. And now let's call the print method from the superclass vehicle. Okay, so let's run the code, and you see the results right here in the console. Type, motorcycle, model, Kawasaki, and max speed 180. Excellent, excellent. Method overriding. So if you define a method in a subclass that is already defined in the superclass with the same name, same parameter, and the same return type, that is known as method overriding. So in this case, the method in the superclass is called an overridden method, and the method in the subclass is called the overriding method. So let's just do a simple example to understand it better. So let's say we have two classes, right? a superclass vehicle and a subclass car. The car class extends the vehicle class. Now, both of the two classes have a common method, right? The void stop. The car class gives its characteristic to the stop method. So it overrides the stop method. It prints the car has stopped instead of vehicle has stopped. Got it? Cool. Let's do up some examples so that you can play along with me and understand the benefits of method overriding. So in the Object-Oriented Programming project, just right-click on the source folder and select New and Class. Specify a package name as Method Overriding and the class name as Vehicle. Now, Vehicle is our superclass. And then let's declare 3 public void methods in the vehicle class. First one is public void start. We print the vehicle has started message using the print method. And then the second one is public void accelerate. So this method takes one parameter that's named speed. And then we can print vehicle accelerates according to given speed. And then we use the speed variable in the print method. And then the last method is stop. In the stop method, we print vehicle has stopped as our message by using the print method. Okay, so remember to save the code. Right. Now let's create a new subclass. So just right-click on the method overriding package and select New Class. Specify class name as car. And in order to implement the method overriding, we have to add extends as our keyword after subclass car. Now our subclass car extends the superclass vehicle. So this means that subclass car inherits all the methods from the superclass vehicle. And the car class is empty now. So the question is, why do we need this method overriding? What we'll do here is let's create a main test class that we'll name override test in the same package. So in the main method, we create a vehicle object. First, we call the start method from the vehicle class. And then we call the accelerate method by passing the value of 80 of speed as a parameter. And then the last we'll call the stop method. Okay, so let's run the code. So you see the results in the console. Yeah? The vehicle has started. Vehicle accelerates at a speed of 80. And the vehicle has stopped. Now let's create a car object to test. And we call the start method and then call the accelerate method by passing the speed value of 100 as a parameter and then call the stop method. Okay, so let's run the code. And you see the same results. The vehicle has started. Vehicle accelerates at a speed of 100 and the vehicle has stopped. But now, do you see it? There is a problem. We wait on properties of car, not vehicle in the second part. So we need to override the methods of the superclass vehicle in the subclass car. So let's override these methods, and you'll see what I mean. Open the car class. Now let's copy the methods of the superclass vehicle, and let's make the changes for implementing the properties of the car class. So we print car has started in the start method instead of vehicle. And we print car accelerates according to given speed instead of vehicle. And then we print the car has stopped in the stop method instead of vehicle. So you see what I'm doing here? These three methods have the same name, same parameter, and same return type with methods in the vehicle class. This is a rule for overriding. So remember to save the code. All right, so let's open the main class, override test, and let's run the code. And you see two different messages coming from the methods of classes. In the first part, we display messages from the superclass vehicle. In the second part, since we override the methods of the superclass vehicle in the class car, car has started, car accelerates at speed 100, and car has stopped are the messages that are displayed. So I hope that's clear as mud and you understand method overriding. It's very useful. Super and this keywords. Super is a keyword that's used to access the superclass members from the subclass. Super as a keyword gives us simple access to constructors, fields, and methods of the superclass. So in our example, subclass car class is using a super keyword to access stop method of the superclass vehicle, right? This keyword is used to access the same class members inside the same subclass. In our example, subclass car class is using this keyword to access its own start method. So we can also access other members of this class, such as variables and constructors, using similar methods. Let's see some examples of using the super and the this keyword. So we're going to open the Object-Oriented Programming project by right-clicking on the source folder and then selecting New, Class, and then specify the package name as super this, and the class name as vehicle. So the vehicle class is a superclass. So let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with a string type, and the variable max speed with int type. Let's declare a public constructor that's named vehicle, and we'll give it 3 parameters, type, model, and max speed. So in the constructor method, we can assign a parameter variable type to the variable type of this class. And we assign the parameter variable model to the variable model of this class. And then the last one, we'll assign a parameter variable max speed to the variable max speed of this class. So we use the this keyword to access the same class variables. So let's generate the public getter methods of these variables to access from the main method. Now, in order to generate getter methods, we can just right-click on the file and select Source, Generate Getters and Setters. And we choose Get Methods of all variables, and then click on the Generate button. And all selected getters methods will be generated automatically. And remember to save the code. Okay, so let's create a new subclass. So right-click on the Super This package, and then select the new class. Specify the class name as car. Our subclass car extends the superclass vehicle. So this means that the subclass car inherits all the methods and variables from the superclass vehicle. Now look at this, we get a compilation error. So if you hover the mouse on the car class, Eclipse will show you a quick fix dialog, and we defined a constructor in the superclass vehicle. So now we must define an explicit constructor in the subclass car, and we must invoke the superclass constructor from this constructor by using the super keyword. So we can add a constructor by selecting the Add Constructor in the Quick Fix dialog of Eclipse. Told you Eclipse was handy. So Eclipse automatically added the constructor with super as our keyword. Okay, so now in the class car, let's declare the variable is automatic with the Boolean type. So its initial value is false. And then we add the variable is automatic to the constructor of the car class as a fourth parameter. And then we assign a parameter variable is automatic to the variable is automatic of this class. Now we need to generate a getter method again of the variable is automatic in order to access it from the main method, right? And I know you like to do this, so we generate the getter method of the variable using the same way we did before. See, you're getting the hang of it, huh? Remember to save the code. And let's create a main test class that's named Super This Test in the same package. Now, in the main method, we create a car object by passing parameters. The first parameter, car, represents type of car. Second parameter, Ferrari, represents model of car. The third parameter, 320, represents the max speed of car. And the last parameter, true, represents is automatic of that car. So we print the properties of the car class by using the print method. And in the first print method, we display the type of car and invoke the getType method from the superclass vehicle. In the second print method, we display the model of the car and invoke the getModel method from the superclass vehicle. And in the third print method, we display the max speed of the car and invoke the getMaxSpeed method from the superclass vehicle. Now in the last print method, we display the is car automatic or not. So we invoke the is automatic method from the subclass car. Great. So, okay, it looks great. So let's run the code. And you see the results right here in the console. Type is car, model is Ferrari, and the max speed is 320. And these properties come from the superclass vehicle. But car is automatic is true. That's right, because this property comes from the subclass car. Final keyword. It's not the final keyword, but it is final as a keyword. Now, as I hope that you remember, and I'm sure that you understood at the time, in the inheritance subject, the inheritance provides reusing existing codes, but sometimes we need to limit some of the properties for, well, many, many reasons. The final keyword allows us to do this. So think of it as a limiter. In this section, we will look at what the final keyword actually means for classes, methods, as well as variables. The final keyword can be implemented in class, methods, and variables. Final classes cannot be extended. So if we try to inherit from a final class, we get a compile error. Java core libraries have many final classes. Final methods cannot be overridden. So when we design a superclass and we want to make sure that the method in this class won't be overridden, we'll make this method final. Final variables cannot be altered. So we can initialize a final variable, but we cannot reassign a new value. So final variables are used to create constant variables. Okay, great. So let's do some examples so that we can both understand this a little bit better. Just kidding. So in the Object-Oriented Programming project, right-click on the source folder and select New, Class. Specify the package name as Final Keyword and the class name as Vehicle. Vehicle class is a superclass. Now let's declare an instance variable that's named Model with a string type in Vehicle class. And let's declare a void method, showMaxSpeed. And then we print max speed of vehicle is 180 as a message. How? Using the print method. And remember to save the code. Okay, so now we can create a new subclass. So right-click on the final keyword package and select New Class. Specify the class name as car. So our subclass car extends superclass vehicle. So this means that the subclass car inherits the showMaxSpeed method and the model variable from the superclass vehicle. Now in the car class, we can override the maxSpeed method of the superclass vehicle. And we can print the message, max speed of car is 320, by using the print method. So remember to save the code. Now we want to limit some properties by using the final keyword. So let's open the vehicle class. For example, if we add the final keyword to a class definition of superclass vehicle, then save the code. So let's open the car class and see we get the compilation error. So let's look at it by just hovering your mouse over vehicle. And the error message is the type car cannot subclass the final class vehicle. So Remember, final classes cannot be extended. I thought that sounded familiar somewhere. So we'll select Remove Final modifier of the vehicle class. And now let's open the vehicle class. And you see, Eclipse automatically removed the final keyword. For example, if we add the final keyword to a method definition of superclass vehicle and save the code, let's go ahead and open the car class, and we get a compilation error. So let's look at that. Placing the mouse over show max speed. Okay, so there's the error message. You cannot override the final method from vehicle. So, final method cannot be overridden. You thought I was making this stuff up. So, we'll select remove final as a modifier vehicle dot show max speed method, and then save that code. So now let's create a main test class that's named final test in the same package. And in the main method, we create a car object. So first, let's open a vehicle class and add a final keyword to the variable model. Now we have to initialize this variable. So we just initialize the string with double quotes. And remember to save that code. Now let's open the main class again. So if we assign Ferrari as the value to our variable model, we get a compilation error. So let's look at that by hovering the mouse on the model variable. And the error message is the final field vehicle.model cannot be assigned. So final variables cannot be altered. So now we will select remove final modifier of model and save the code. Now let's call up show max speed. Okay, so run the code. Now you see the result in the console. Overridden show max speed method is invoked and it displays the max speed of the car is 320. Abstract classes. So an abstract class is used to implement common features of related classes. So it's declared with the abstract keyword. If a class has at least one abstract method, then the class must be declared abstract. Also, abstract classes may contain non-abstract methods and variables. You cannot instantiate an abstract class. That means that you cannot create the object of it. So in order to use abstract as a class, we have to inherit it from another class. So you can think of an abstract class as like a template. You must extend it and override the abstract methods. An abstract method is also just a prototype. So it has no body and contains the following attributes: a return type, a method name, and a list of parameters. Methods and members of an abstract class can be defined with any visibility, such as public, protected, private, etc. So in our example, vehicle is an abstract class that contains only one abstract method. Get max speed, right? Remember, it's got no body. Because the implementation of this method is provided by the car and motorcycle classes. You were wondering why that was empty, huh? No body. So the car and motorcycle classes have to override the abstract getMaxSpeed method of the superclass vehicle. Okay, so I heard a couple of pennies drop. So let's do up some examples and we can understand the abstract class a little better. So in the Object-Oriented Programming project, right-click on the source folder and select New Class. Specify the package name as Abstract Class and the class name as Vehicle, and choose Abstract to create the abstract class. The vehicle class is an abstract superclass. So let's declare two instance variables that are named type and model with the string type in vehicle class. So let's declare a public constructor that's named vehicle, and it contains two parameters, type and model. Now in the constructor method, we can assign a parameter variable, type, to the variable type of this class. And then we assign parameter variable model to the variable model of this class. And now we can use the this keyword to access the same class variables. Now let's declare two non-abstract void methods in the vehicle class. First one is public void start. And then we print the message vehicle has started by using our print method. So the second one is public void stop. And then we print the message vehicle has stopped by using the print method. Now we can declare an abstract int method that's named getMaxSpeed with no body. And now we must implement this method in the subclass. And here's where you remember to save the code. Okay, so now we're ready to create a new subclass. So just right-click on the abstract class package and select New Class. And then specify the class name as car. Now our subclass car extends the abstract superclass vehicle. So this means that the subclass car inherits all the methods and variables from the superclass vehicle. But wait, we get a compilation error. So what do? We just place the mouse on the car class and Eclipse shows us the quick fix dialog. So we defined a constructor in the abstract superclass vehicle. So that means we must define an explicit constructor in the subclass car. And we must invoke a superclass constructor from this constructor by using the super keyword. So we can add the constructor by selecting the Add Constructor in the Quick Fix dialog of Eclipse. And look at that. Eclipse auto-magically added the constructor with the super keyword. Now also, if you go back and place the mouse pointer on the car class, Eclipse will show us this quick fix dialog. So we must implement the abstract method getMaxSpeed in the car class. So we select the Add Unimplemented Methods, and then Eclipse automatically added getMaxSpeed as a method with the override annotation. So let me give you a little bit of history. Way back in Java 5, annotations were introduced. So an annotation always starts with the @ symbol, followed by the annotation name. So whenever you override a method of a superclass, it's always best practice to include the override annotation. The override annotation is also used for making code readable as well as avoiding any maintenance issues down the line. So now that we're having fun, let's override some other methods of the superclass vehicle. Now, there's no obligation to override non-abstract methods of abstract superclass vehicle. So let's copy the non-abstract methods of the superclass vehicle, and let's make some changes for implementing properties of the car class. So we use the car has started in the start method instead of vehicle, and we use the car has stopped in the stop method instead of vehicle. So let's add the override notation to these methods. In the getMaxSpeed method, we declare a final variable, max car speed, in uppercase letters, and then assign this variable to 320. Now, it really is good to get in the practice to use final variables using all uppercase letters and underscores as a separator. So now we print max speed of car by using the print method. And then return the variable max car speed. Remember to save the code. Now let's create a main test class that's named abstract test in the same package. So in the main method, we create a car object by passing parameters. The first parameter, car, represents the type of car. The second parameter, Ferrari, represents the model of the car. Now let's call the overridden start and stop methods from the subclass car. And let's call the overridden abstract getMaxSpeed method from the subclass car. Okay, so let's run the code. And you can see the results right here in the console. Overridden start method was invoked, and car has started is the message that we see displayed. And then the overridden stop method was invoked, and the car has stopped message was displayed. And then the overridden abstract getMaxSpeed method was invoked, and the max speed of car is 320 message was displayed. Interfaces. Interfaces are a set of common behaviors that are implemented by multiple classes. Interfaces can only have constants and methods without a body. So the interface really can't do anything, it's just a pattern. You cannot instantiate an interface, so it means that you cannot create the object of it. An interface does not contain any constructors. An interface is not extended by a class. It is implemented, however, by one or more classes. A class can implement multiple interfaces. So basically, an interface simply is saying, I can do these things, right? So we give a promise to the compiler, so to speak. So in our example, we first define drivable as the interface. So this interface has two methods that are named turn left and turn right with no body, right? Car and motorcycle are the classes that implement this interface. So it means that both of the classes can turn left and can turn right. So the turn left and turn right methods, they must be implemented in the car and motorcycle classes. It's an absolute obligation. All right, so I think that's pretty clear. Why don't we do up some examples with an interface? So go back to the Object-Oriented Programming project, right-click on the source folder and select New Interface, and specify a package name. So let's call it Interface Class. And then the interface name, Drivable. So an interface only declares method names without a body. So we must implement all methods of interface. So let's declare two void methods with no body in the drivable interface. So the first method is turn left, and the second method is turn right. Remember to save the code. Okay, so let's create a new subclass. So right-click on the Interface Class package and select New Class. Specify the class name as car. Now we can add implements as a keyword after the class definition of car. Car implements drivable means that turn left and turn right are the methods in the drivable interface, and they must be implemented in the car class. But hold on, you say, we get a compilation error. So let's hover the mouse pointer on the car class, and Eclipse shows us a quick fix dialog. Okay, so we must implement an abstract method turn left and turn right in the car class. Okay then. So then we select Add Unimplemented Methods, and then Eclipse automatically adds these methods with the override annotation. You thought I was losing my mind. So let's fill the rest of these methods. In the turn left method, we print car can turn left as a message by using the print method. In the turn right method, we print car can turn right as our message by using the print method, and we save the code. Okay, so now let's create a new subclass. Just right-click on the Interface Class package and specify the class name as Motorcycle. And we add the Elements keyword after the class definition of Motorcycle. So Motorcycle implements drivable, means that turn left and turn right are the methods in the drivable interface that must be implemented in the Motorcycle class. And now we select the Add Unimplemented Methods to add the methods of interface with the override annotation. All right, so let's fill in these methods just like we did in the car class. In the turn left method, we print Motorcycle can turn left for our message by using the print method. And in the turn right method, we print the Motorcycle can turn right message by using the print method. And remember to save the code. Now let's create a main test class that's named Interface Test in the same package. So in the main method, first we create a car object. So let's call the overridden method turn left and turn right from the class car. Secondly, we create a motorcycle object. And then let's call the overridden method turn left and turn right from the class motorcycle. Okay, are you ready? Let's run the code. And look at that. You see the results right there in the console. The car can turn left and the car can turn right. The motorcycle can turn left and the motorcycle can turn right. See? Autonomous vehicles are very easy to program. That's just a joke. Polymorphism. So polymorphism, because I promised I'd tell you about it, is used to perform a single action, but in different forms. So in Java, we have two types of polymorphism. The first one is static, and the second one is dynamic. So method overloading is an example of static polymorphism. Method overriding is an example of dynamic polymorphism. So in the slide here, you can see dynamic polymorphism. So for example, we have a vehicle superclass, and it has an accelerate method. And we have two subclasses that override the accelerate method of the superclass vehicle. An accelerate works for any type of vehicle, right? Not only a car, but also a motorcycle. The accelerate action is done in a different form in the car and motorcycle classes. So when we create an object of the subclass and then assign it to the superclass reference, if we call the overridden accelerate method on the superclass vehicle reference, then the overridden method of the subclass will be called. So let's say if we want to create two objects, vehicle equals new car. Now that's a statement that works because car is a subclass of vehicle, okay? So here the reference variable, vehicle, declared the type of vehicle is pointing to an object of the car class. So in the same way, vehicle1 equals new motorcycle. That works as a statement because motorcycle is a subclass of vehicle as well. So here the reference variable vehicle1 is declared, type vehicle is pointing to an object of the motorcycle class. And this very useful feature of Java is named polymorphism. So now to bring it home, let's do up some great examples so that we can understand polymorphism in all of its flavors. So we implemented static polymorphism that includes the method overloading in the method section. So we will implement dynamic polymorphism that includes the method overriding in this exercise. Okay? So go back to the Object-Oriented Programming project, right-click on the source folder and select New Class. Specify the package name as polymorphism and the class name as vehicle. And the vehicle is our superclass. So now let's declare a public void method that's named accelerate in this class. And then we print vehicle is accelerating for the message using the print method. And remember to save the code. Okay, so let's create a new subclass. So just right-click on the same package and then select New Class, and then specify the class name as car. So our subclass car extends the superclass vehicle, and this means that the subclass car inherits the accelerate method from the superclass vehicle, right? So now let's override this method. We can start with the override annotation, but it's not mandatory here. We'll write accelerate as the method again to override. Now in this method, we can print car is accelerating for a message, and we save the code. Okay, so now let's create a new subclass. So right-click on the same package and select New Class. Specify the class name as motorcycle, and our subclass motorcycle extends the superclass vehicle. So now we write the accelerate method to override by adding the override annotation. And then in this method, we print the message motorcycle is accelerating, and then we save the code. Okay, so let's create a main test class that's named test in the same package. In the main method, first, create a vehicle object reference by pointing to the car class. And this code works because car is a subclass of vehicle, right? So the class vehicle is extended by the class car, and its method accelerate is overridden in the class car. So in this definition, the reference variable vehicle is pointing to an object of the car class. So if we call the accelerate method, it will print the car is accelerating message. You don't believe me? Let's run the code. And you can see it right here in the console. Cars.
Okay, so as we reach the conclusion of our Android development course, it's inspiring to look back at the journey we've taken together. So over the past weeks, no, we've explored the fundamentals of Android app development, from designing user interfaces and managing data to implementing navigation and leveraging external APIs. So each module was crafted to build on the previous one, no, empowering you with a solid foundation in creating functional and engaging mobile applications. So your dedication to learning, experimentation, I mean, in hands-on practice has been the driving force behind this course success. So throughout this course, we tackled various challenges and embraced new concepts, tools, and frameworks. So we examine not only the technical aspect of Android development, but also the principles of user-centeredness design, app optimization, uh, and effective debugging. So these skills are critical in the real world, no? Where Android developers must balance functionality with user experience to create impactful application. So the progress you've shown from your first line on the code to your final projects now demonstrate your readiness to take on take one more advanced challenges and contribute meaningfully to the mobile development field. So as we close this course, no, remember that this course is just the beginning. No, the world of Android development is constantly evolving with new updates, tools and best practices emerging regularly. So I encourage you to continue exploring, experimenting, and honing your skills. So the foundation you built here will serve as a springboard for your further learning. So whether through advanced courses, personal projects, or professional work. Congratulations on your achievements, and I look forward to seeing the innovative applications you'll develop in the future. So keep coding, stay curious, watch some video tutorials available in YouTube and some blog, and embrace the endless possibilities of Android development. God bless everyone.